Well, hi everyone. It's great to see you out there. I'm Matthew Whitehouse. I am the observatory manager here at the South Carolina State Museum. And today we're sharing a live image of the sun through our telescope. So we here at the observatory have a special solar telescope that's mounted on top of our large telescope. And that telescope has a lot of filters in it which allow us to look at the sun safely. So what you're seeing right now is this live video feed of the sun from our telescope. Today we've got some really nice sunspots. You can see that one up towards the upper right, and then there's some smaller ones. They're like 3 down to the lower left. So the cool thing about these sunspots is each one of those black spots is actually at least the size of the Earth. And actually, they might be larger, especially that one up towards the upper right. Now, sunspots are caused by magnetic disturbances on the sun, keeping hot gases from rising up from the center or from the interior of the sun, rather. And because that happens, sunspots are actually a little bit cooler than the surface around them. Now, this is an interactive format, which means that if you have any questions, feel free to pop those questions in the Facebook or YouTube comments, and I will see them here and I will do my best to answer them on air. So feel free to ask any questions you might have. So one of the things you might be noticing is that we have this black and white view of the sun. Sometimes people look at our view of the sun and they think, oh, it looks like it's the moon. And that's because we're actually using a black and white camera. But I'm going to show you a neat trick that I have. So let me pull up our camera control software here. And we are going to change the color. So what I've done here is I've actually let our software that's driving our camera add color. So it's not the true color of the sun, but it actually gives you an idea of what the sun would look like from the telescope if you were looking through uh, the telescope with your eye. Which, by the way, is safe to do, once again, because we're using a solar telescope, and solar telescopes are filtered. So don't try this at home. So once again, if you have any questions about these sunspots or anything you're seeing here, feel free to ask. I see Becky says, I'm tuning in from work. So neat. Welcome, Becky. Glad you could join us today. Um, so I'm going to change the camera setting again because there's something else cool I can show you. So let me pull up our software again, and I'm going to turn the camera exposure up a bunch. And you will see along the edges those gas eruptions down there, especially to the bottom right. So that gas eruption to the bottom right is called a prominence. It's not as powerful as a solar flare, but it is a large eruption of gas that is extending off the surface of the sun. And just looking at this, I think that prominence could be 30,000 miles high, maybe 50,000 miles high. They're really, really big. They're not as explosive as solar flares, once again, but they are giant. So there are some smaller prominences you might, especially if you're looking on a computer screen, it might be harder if you're looking on your phone. You might see that prominence up towards the upper right. There's a little tiny one. Um, Not nearly as noticeable as the one to the lower right, but there is a tiny one up towards the upper right as well. So once again, if you just joined us, feel free to ask questions in the Facebook or YouTube comments. We love taking questions on air, and I will do my best to answer those questions that you might have online. So feel free to chime in if you're curious about anything. I'm actually going to change the view back so that we can see those sunspots. The sunspots are actually really kind of cool today. So we actually went through a period kind of like last week, I think, where we didn't have a lot going on in the way of sunspots. It's actually last week and I think a little before then. So we had a period when there were a bunch of sunspots, then we went through a period when we didn't have any or didn't have very many, and now we've got some sunspots back. Now, just because the sun didn't have sunspots, that doesn't mean that they actually weren't there. It just meant that we couldn't see any from Earth. It's totally possible that the suns had sunspots on the other side of the sun where we couldn't see them because that side was facing away. I actually am noticing now that there's another sunspot. It's way, way over to the left. It looks like it's just rotating into view. And you might, again, if you're on a phone, have a little bit of trouble seeing it. But again, sunspots, there's a big one to the upper right. There's a group down towards the lower left of center. And then there's one at the lower left all the way over to the very edge. And once again, these sunspots are about the size of the Earth. So one of the things that I always like to point out about the sun that's really cool is we're actually looking at a star. So the sun is our closest star. And because it's our closest star, it's actually the only star that we can see in this level of detail. So we can see day-to-day changes on the sun. We can actually see features on the sun's surface. We can see those sunspots. We can see those prominences. When we look at other stars with a telescope, they're usually so far away that they just look like little points of light. So it's really, really cool to be able to see a star up close. So if you want to learn about stars in general, a great place to start is to study our sun because we can see it up close and personal, so to speak. So the other thing about the sun is that it looks like a very big, bright star to us. It's certainly the biggest and brightest star in our sky, much bigger and brighter than the stars that we see at night. Of course, the stars that we see at night look like little points of light. The sun, we can actually feel the heat from it, especially on a July day here in South Carolina, let me tell you. And it's just a whole lot closer to us. But the thing is some of those stars we see at night are actually a lot bigger and brighter than the sun. They're just a whole lot further away. So that's why they look like little points of light. So we're going to pose a question for you here. So do you think that, and this is kind of what I was talking about, so I sort of gave you the answer a little bit. Do you think the sun is an average sized star, or do you think it's the biggest star? Do you think there are stars in space that are much bigger, much smaller than the sun? What do you think? Put in the comments just a little bit about what you think about how big the sun is compared to other stars. Again, I kind of gave the answer away just a minute ago, so let's pop that back to you and see if we can get a few little comments. So again, well, how big is the sun? Is it average? Is it bigger than most stars? Smaller than most stars? So no comments. It looks like we're just all enjoying the view. So once again, if you just joined us, we're looking at a live image of the sun from our telescope. Whoa, did you see that? Who saw an airplane flying? Okay, Patty says smaller than most stars. Very good. Yeah, so the sun is actually kind of just an average sized star. Now, I want to know who out there in the audience saw that airplane flying across the sun. Any of you see that? Post in the comments if you saw that airplane flying in front of the sun. So, of course, when we see something like that happen, that's really kind of cool to watch. The thing, of course, to know is that that airplane is nowhere near the sun in reality. It's just probably a plane from one of our local airports or that happened to be flying over the museum, and it flew through our view of the sun from the telescope. And when that happens, it can be really kind of fun to see those planes flying through the view. It's actually fairly common. We see little black spots flying through our image all the time. Those are actually probably birds. Planes are a little bit less common, but they certainly do happen. The other thing we commonly see are these sort of dark things drifting in front of the sun. Those are actually not on the sun at all. Those are actually our own clouds. Fortunately, today it doesn't look like we are seeing any clouds in our image. The clouds that we had this morning have largely dispersed, so we're able to show you a nice clear view of the sun. But if it were cloudy or a little more cloudy, you might see some dark things passing in front of the sun. So I'm going to change a camera setting again here. So right now we're looking at the view that allows you to see the sunspots. But I want you to also be able to see the prominences. So let me adjust the camera here, bring up my controls, and let's get a view of the prominences. Whoa, there we go. So today especially, there is that prominence down there to the bottom right. And that prominence is a large gas eruption. It's probably extending a good 30,000 miles or more off the surface of the sun. It's not as powerful as a solar flare. Solar flares are much more explosive than prominences are, and they happen very, very quickly over the course of just a few seconds. But that prominence is a really big eruption of gas. It's taking up a lot of space as it oozes off the sun. So does anyone know or want to take a guess at what causes prominences? Just if you have any ideas, post those in the comments. And it's okay if you are really not sure or you have maybe an idea that you want to test out. I'm just curious as to if folks have some thoughts about what causes the prominences. I'll give you a hint. Prominences and sunspots are actually caused by the same thing or very similar processes. So if you have an idea, pop in the comments what you think causes prominences. So while people are thinking, I will say that sometimes prominences are a lot larger than like 30 to 50,000 miles. You can actually get prominences that can be 150 to 200,000 miles long. It's not super common, but it certainly does happen. There was actually, we got a prominence like that about a month or so ago, and there was actually a post recently on our Facebook page with a picture of that very large prominence. That was, I think, posted over the weekend. So go back and look at our Facebook page if you're curious about seeing a really, really long prominence. So right now, we're also open to the public, so to visitors here at the museum. So that's actually a group that's walking into the observatory with our educator, Caitlin, and they're going to have a look at the sun as well. So once again, any ideas as to what causes a prominence? And I'll also tell you that I have no clue is a perfectly fine answer. Shall I tell you what causes prominences? I shall. So prominences are caused by the magnetic field of the sun. Those magnetic field lines will extend off the surface of the sun, and they will pull the gas from the sun's surface along and pull it out into space. So that's what causes prominences. So really anything that we see kind of interesting on the sun is typically caused by the magnetic field of the sun doing something. So sunspots are places where the magnetic field has gotten all tangled up, like my fingers right now. And that's where hot gas can't rise up from the inside of the sun, so you end up with a spot that's cooler, which is just why prominences look darker. They're not cold, they're just a little cooler than the surface around them. And then sometimes you'll have the magnetic field of the sun in spots kind of explosively snap, kind of like bang, like that. And when that happens, that's when you release a lot of energy and you get things like coronal mass ejections, solar flares, all those things that can affect us here on the Earth by causing the northern lights and southern lights, the aurora borealis and aurora australis. They can also do things like mess with our satellites. They can even do things if they're a really big flare or big CME, they can do things like knock out our power grid in spots. So this is actually one of the reasons we study the sun, is because the sun affects us here on the Earth. We're basically living with a star right here in our backyard. So we want to know what the sun is doing. So I'm going to pop back to our view of the sunspots. So we've had a view of the prominences here. I'm going to switch back to sunspots for us here. I'm going to pop up my control software. We're going to adjust the camera exposure down. And we're going to have a look at those sunspots again. There we go. So if you're trying to find where the sunspots are, there's a big one to the upper right. And then there is a smaller group, or group of like 3, or actually probably more than 3 smaller sunspots down towards the bottom left of center. And then there's another sunspot that is probably going to be a little tricky to see, particularly if you're watching on a phone. That sunspot is way over to the bottom left edge. So way, way over on the edge of the sun. So these sunspots are each about the size of the Earth. Some of them, especially that one up there in the upper right, actually could be quite a bit larger. It could be like twice the size of the Earth. So it's kind of gives you a sense of how big the Earth is compared to the sun, or how small the Earth is compared to the sun. And to give you a further idea of scale, we could fit about 100 Earths across the sun and 1 million Earths inside the sun. How about that? And again, even though the sun can swallow up 1 million Earths inside of it, the sun is only an average-sized star. There are stars that we see, especially the brighter ones we see in the night sky, that are much, much bigger and brighter than the sun. They're just a whole lot further away. And actually, as we get later into the year, we're right now in late October, of course, but if you go outside right now, like after midnight, if you look in the east, you'll see the constellation Orion rising. And actually, Orion has several bright stars in it. And these are some really great examples of stars that are much, much bigger and much brighter than the sun, but a whole lot further away. You have stars like Betelgeuse and Rigel, and then the 3 stars in Orion's belt. Those are all stars that are much bigger and brighter than the sun. So actually, as we get into the winter sky, it's really a cool period to go outside and go stargazing. I said cool, winter, cool. Yeah, I know that was kind of a bad pun because it does get cold in the winter. At least it should. Of course, this is South Carolina, so who knows what winter's actually going to be like. But as we get into the winter sky is actually one of the best times of year to see a whole lot of bright stars. So right now, if you go outside again in the early morning, you'll see the winter constellations rising in the east. As we get into kind of around Christmas or so, the constellation Orion will be rising in the east just after it gets dark. And by the time we get into the early part of the new year, so like late January, early February 2023, when we go outside as it's getting dark, Orion will be really high up in the south with all of its bright stars. So once again, if you just joined us, we're looking at a live image of the sun from our telescope here at the South Carolina State Museum. And we'll have this up for about another 10 minutes. We're going to end this live stream at 4 o'clock. So the things you're seeing here are sunspots. Oh, I saw something else kind of fly through the image there. I don't think that was a plane. I think that was a bird, but I'm not sure. It was kind of was down towards the bottom left. Something flew through. So again, we have that sunspot up there to the upper right. That sunspot is at least the size of the Earth. It's actually probably larger. And then there's that group of sunspots down to the bottom left of center. And then there's one sunspot that you might have a hard time seeing that's out towards the very edge there on the bottom left. So, have any of you ever seen the Northern Lights? I'm just curious. If you have, post in the comments. Maybe you went on a trip to Alaska or Canada or something like that. Any of you ever seen the Northern Lights? So I actually haven't ever seen the Northern Lights myself. I hope to. My parents actually were on vacation in Alaska back in September, and on their flight back, they were flying from Anchorage to Atlanta. And when they were flying over Alberta in Canada, they were on the left side of the plane. So they were on the side of the plane facing north, and they actually did see the Northern Lights. So my parents have seen them. I haven't. And you know what? I'm really jealous. But again, when the sun does things like have solar flares and that kind of stuff, that's when we're more likely to see those northern lights, those aurora. Of course, hard to see them here in South Carolina. So I just saw we had a viewer pop on. So if you're new, welcome. We'll be showing this live image of the sun from our telescope here at the South Carolina State Museum in Columbia until 4 o'clock. And then we'll have to turn off our live stream so we can interact with guests who are actually here at the museum. But what you're seeing here is a view of the sun through our special telescope that's filtered. So if you're just now popping on, this is actually a live image of the sun from our telescope here at the South Carolina State Museum. We're using a special telescope that's filtered so we don't blow anything up. So don't try this at home. And that black spot that you see there on the upper right, that is a sunspot. And that sunspot is at least the size of the Earth and actually could be more like twice the size of the Earth. That's actually not the only sunspot we have today. There is another group of sunspots down towards the bottom left of center, and those are smaller. And then there's another sunspot way over to the lower left edge that you might have a hard time seeing. So if you are just joining, I can actually show you a different view of the sun here. So just hang on for a minute while I change camera settings. Here we go. Very cool. So if you just happen to join us, there's actually, this is a live view of the sun from our telescope here at the South Carolina State Museum, and you can see that large gas eruption down towards the bottom right. That's called a prominence, and it's probably about 30,000 miles long. Could be larger. So if you're just joining us, we're looking at the sun here from our telescope at the South Carolina State Museum. I'm going to change a camera setting here. There we go. Whoops, changed it a little more than I wanted to. There we go. So now we're looking at this view of the sun. Again, this is a filtered telescope, so this is safe for our eyes and our camera, so don't try this at home. But that large black spot there up to the upper right, that's called a sunspot. And that sunspot is at least the size of the Earth. So if you just hopped on, we're right here at the very end of this showing of a live image of the sun from our telescope here at the South Carolina State Museum. We're doing this with a filtered telescope, so it's totally safe. Don't try this at home. And that black spot that you see up there to the upper right is called a sunspot. And that sunspot is at least the size of the Earth, might be more like twice the size of the Earth. So if you just jumped on, we're looking at a live image of the sun from our telescope here at the South Carolina State Museum. We're using a filtered telescope, so it's safe. So don't try this at home. That large black spot you see up to the upper right is called a sunspot. And that sunspot's at least the size of the Earth, maybe more like twice the size of the Earth. So unfortunately, we've come to the end of our time, so I'm going to have to say bye. So thank you so much for joining us, and we'll see you later. Watch the South Carolina State Museum's Facebook page and website to look for any more of these live stream programs that might come up in the future. See you all later. Bye.